So this is my solar controller system. You can see this is the solar controller module. Battery would be connected with this module. So when the solar panel will be connected to this point, and my DC supply connect to this point. So during the day, the solar panel will supply to the solar controller, and during the night the DC supply will take control. So I have configured this circuit like that, so when the solar voltage reaches like 12 volt or something, then this transistor will conduct, and it will turn on this PNP transistor, and this MOSFET, this is P channel MOSFET, this MOSFET will switch off, so that if I don't switch off my DC supply, it will automatically switch off, like to save the power. During the day it only take power from the solar panel, not from the DC supply. Actually that was my intention here for this circuit. So this is the solar controller. Battery will connect to this. So this is my test setup. I have attached a 12 volt adapter to this DC point, and right now for the testing purpose I have attached another 12 volt supply at the solar point. So my DC supply is going through this ammeter, so that I can see the current consumed by this test load. So now if I give power to the 12 volt adapter, you can see it is consuming like almost 400 milliampere. Right now the solar this point I don't give any power at this point. So look, if I give 12 volt to this point, the consuming of the DC should be less, like this. But during the night, if I switched off the solar, the DC supply will cover up the charging voltage for the battery. So this is the circuit. This is the MOSFET, P channel MOSFET. This is the Schottky diode, and this is the output section. This section is supposed to be connected to the charger controller or the battery. And this is for the DC supply voltage in case of night or no sunlight available, and this is the connector for the solar panel. For the testing purpose, I have connected the solar point with my variable power supply, and the DC with a 12 volt fixed power supply, and it is coming through this milliampere meter, so that I can see how much current is drawing during the daytime or night time. So as a load, I have used LED, just LED, to minimize the current draw. So let's switch it on right now. I will switch on the DC first, and we'll see the current consumed. So as you can see, the DC supply is on right now and it is taking like 10 milliampere almost. So suppose this is the night time, so the DC supply will will supply the charger controller like that. So now during the daytime we'll switch on the solar and we'll see what will happen. So I have just switched on the solar. I am increasing the voltage right now. 9 volt, 10 volt, 11.3, nothing happening. 11.9. As you can see, the milliampere meter already down a little. If I decrease the voltage, solar voltage is getting back there, but at about 11.9 volt or 12, the power consuming is getting very less. I'm increasing the voltage and LED is off at about 13 volt, and the DC consuming is almost 0, although the DC is connected with the controller. DC current draw is almost 0. Now at about 6 p.m. the LED is so this is early in the morning. Sun is not at the full bright, but I can see solar panel is already taking control of the charger system. Now sun is at the full bright. As you can see, voltage is getting high and my DC LED is switched off. That means it's not consuming any DC current right now. The controller, solar controller, is taking charge from the solar panel itself. Coming out from the controller.